In this lesson, we're going to cover simplifying radicals. Specifically, we'll understand what they are and we'll learn to simplify, multiply, and add and subtract radicals. First, properties of radicals. So a couple of things. You typically see them written in this form with the radical symbol, an n, and whatever's under the radical. So n is what's referred to as the index. X, or whatever's under the root, is the radicand, and then the symbol is the radical. This is not here. Don't know where that went. So simplifying radicals. So recall we talked about perfect squares or square roots of perfect squares. And in this case, the square root of 25 is just 5. Now, when the index is 2, or when you're taking a square root, it's implied there. So if there's no number there where n goes, it's implied that it should be 2, or that we're talking about square roots. Okay, and one other thing, the reason that the square root of 25 is 5 is that's because 5 times itself 2 times is 25. So that determines how we're going to simplify these radicals. So let's get started. Simplifying radicals. So now we're dealing with numbers and variables. So we have to look at both. So first, the square root of 36 times x to the 14th. The square root of 36, you're looking for a number times itself twice to get 36, which would just be 6 when we simplify this. When we're looking at x to the 14th, we're looking at x to some power times x to some power to give us x to the 14th. And that power has to be the same, so we can't do like 10 and 4. In this case, our answer is 7. 7 plus 7 is 14. So this simplifies to 6, because that's the square root of 36, times x to the 7th, because that's the square root of x to the 14th. Okay? And you can always kind of do a check to see 6x to the 7th times 6x to the 7th. And that's what we have under the root. Moving on to part B, 49, x to the 100th power. Again, there's no index written, so it's implied that it's 2. The square root of 49 is 7. And be careful with x to the 100. 100 is a perfect square, but because this is the exponent of a variable, we're talking about x to the 50th times x to the 50th. So our final answer here is 7x to the 50th power. So notice with both of these examples, the exponent, we cut it in half, and that's because we're taking the square root. Part C, 18x to the 8th. So 18 is not a perfect square, so we have to break this down. You can do 6 and 3, but I'm going to choose to do 9 and 2 because the square root of 9 is 3, and then square root of 2 stays the square root of 2. When we break down x to the 8th, we're looking for x to some power times itself to give us x to the 8th, so this would be x to the 4th. We put this all together, we get 3. I'm going to write the x to the 4th next to it. It's all being multiplied together, so order doesn't matter. It just makes it less confusing as to what's under the root and what's not. So our answer here is 3x to the 4th times the square root of 2. Continuing on to simplifying radicals, what happens when the exponent of our variable is odd? Well, the strategy is to get to the closest even number without going over. So we can rewrite this as x to the 12th times x to the 1st. 12 is even, so we can cut it in half or divide by 2 since we're taking the square root, which would give us x to the 6th, and x to the 1st stays inside because it's not a perfect square and doesn't have any perfect square factors. And the last one we'll talk about is when our index is not 2. So here our index is 3, so we would be looking for a number times itself 3 times to get to whatever's inside of the radical. In this case, it's 27. So our answer here is 3, not because of the index, but because 3 times 3 times 3 is 27. Next, we'll talk about multiplying radicals. So the strategy here is any numbers that are on the outside of the radicals you can multiply together. You can multiply the radicands, what's under the root, and leave it under the root, and then simplify as much as possible. So example 1, multiply and simplify your answer as much as possible. There's no numbers on the outside that we have to multiply together, so we can take 50 times 2 and leave it under the radical symbol. 50 times 2 is 100, and now we simplify. The square root of 100 is 10, so 10 is our final answer. Adding or subtracting radical expressions. So in order to add or subtract radical expressions, the index and the radicand must be the same. So what this means is that we can really only add or subtract like radicals. So reviewing something that we've talked about previously with combining like terms, if we have 8x plus 5x minus 3x, we would have 8 plus 5 is 13x minus 3. This would be 10x. Okay. For the example to the right, if we have 8 square roots of 2 plus 5 square roots of 2 minus 3 square roots of 2, in this case, 2 is playing the role of x like we saw from our previous example, and this would be 10 square root of 2. And so what this means is, for instance, like if this was a y instead of an x, we couldn't combine it. Or if this was cube root of 2, we couldn't combine that one. So we're talking about like radicals, just like we know from like terms. Okay, so perform the operation, simplify your answer as much as possible. So we have 9 square root of 14 minus 8 square root of 14. This gives us 9 minus 8 square root of 14. 9 minus 8 is just 1, and you don't have to write the 1 on the outside. So our final answer here is square root of 14. Square root of 14 can't break down any farther. Thank you for watching. If you have any additional questions, please feel free to reach out to me.